Hello everyone, welcome again to my YouTube channel Maths Plus. So today I am going to discuss a special topic taught in class 10 NCERT mathematics book, that is the chapter polynomial. So in this I will be discussing a topic, graphical representation of polynomials. So you can see I have just written here linear polynomial and quadratic polynomial. Only these two cases I will be discussing. So linear polynomial is what? The general form, as you know, in class 9 also we have studied p of x is equal to ax plus b, where a is not equal to 0 and degree obviously it is 1 because it's a linear polynomial. Here it is given the graph of a linear polynomial is always a straight line as shown in the figure. You see this is the y-axis, this is the x-axis. You must be knowing everyone, these are what? Coordinate axis, isn't it? So y dash, then it is x dash. And this you see they are mutually perpendicular to each other, and the name is what? Origin, this point of intersection, and it is named as O. So when you go for linear polynomial, it is always a straight line, as you say. So it depends upon the coordinates of the lines also. If I say the line will be like this, this represents what? P of x is equal to ax plus b as the linear polynomial or the graph of the linear polynomial. That means you can say after plotting the points of this graph, I got a straight line here. Always you will be getting what? A straight line. So this is all about what? Linear polynomial will be having always a straight line if represented on the graph. Okay. So next is, and we can say there is 1 0 also. 1 0 of this polynomial because it is a degree 1 as we have studied in class 9. So next is very important, which is to be discussed in class 10, that is the quadratic polynomial. Quadratic polynomial is what? Its general form is p of x is equal to ax square plus bx plus c, where a is not equal to 0 as a special condition and degree is always 2. So here I have written here the graph of a quadratic polynomial is always a parabola. In this case, three cases arises. The parabola, how does it look like? The parabola looks like this. Okay, so in this way the parabola looks like. So let us do on the graph. So three cases arises in the sense, the general form as we know, ax square plus bx plus c. Okay, and where a is not equal to 0. So three cases arises in the sense, if I write here ax square plus bx plus c is the quadratic polynomial, and a is not equal to 0, which is a special condition. Here the parabola will be either opening downward or either opening upward. Okay, so if I say in this case, first case, what do you see? The parabola is opening upward like this. So I can say the coefficient of x square, this one, coefficient of x square is positive, but if I say the parabola is opening downward like this, so I will say the coefficient of x square is what? Negative. X square is negative because it is opening downward. The same cases will be arising here also, but what special, what you see here, this parabola is intersecting the x-axis at two distinct points. That's why I will say here there are two distinct zeros. Okay, because it is intersecting at two distinct points on x-axis. Because the zero of quadratic polynomial will be obtained graphically if you want to solve, then I have to see the parabola is intersecting the x-axis or not intersecting the x-axis. You have to see that. In the case 2, what I will do, so here is the coordinate axis, you can see here, and I have drawn this parabola like this. So what you see here, it is opening upward and it has only touched the x-axis. Okay, so I will say here it is a special case again, and if it is opening downward and touches like this, so this is also the case 2. So what you see here, the parabola is just touching the x-axis at one point. Here is also it is opening downward and it is touching the x-axis at one point. Therefore, I will say here, in this opening upward, I can say the coefficient of x square is positive, and here it will be what? If it is opening downward, the coefficient of x square is negative. But I can't say here two distinct zeros. I will be saying here two equal zeros. Two equal real zeros, I can say. And here you see two distinct real zeros. Here also I can say, because these are what? Real numbers. Whatever point you will be getting, coordinates you will be getting at this point, so those are real numbers, because we are considering x-axis as the number line here. Okay. So here two equal zeros because the parabola is just touching the x-axis at a distinct point here. Case 3 is what? It is again another special case. Here the parabola will be there, but thing is that it will not be intersecting x-axis, neither touches the x-axis. So it will be opening like this without touching the x-axis. Here also without touching the x-axis. In both the cases you see parabolas are there, but they are not touching the x-axis, and therefore they are again a special case where if you see it is opening upward, matlab coefficient of x square is positive, and if it is opening downward, coefficient of x square is negative. But here no real zeros or no zeros at all. Why? No, because it is neither touching the x-axis nor intersecting the x-axis at two distinct points. So this is all about the graphical representation of a linear polynomial and a quadratic polynomial. This is a general topic, and broadly if I will be going and discussing, so I will be putting some examples, then I will be drawing a parabola for you. So whatever discussed today regarding the graphical representation of polynomials, it is a short discussion over here, so about a linear polynomial and a quadratic polynomial, and it is a topic in class 10 polynomials chapter, which is the very important topic is this one, the quadratic polynomial. This is a very important topic because every question will be related to this quadratic polynomial in class 10 syllabus. Okay, so this is just a short discussion over the graphical representation of polynomials. Hope you liked this class. I hope you will be waiting for my next video on the basis of this graphical representation of polynomials. So till then, have a nice day.